Consider the separately excited DC motor. In these small motors, the stator is often a fixed magnet, and the rotor is winding. Equations on the rotor side, assuming that the current is constant, determines the direct ratio of rotor voltage and motor speed. Also a direct relationship between torque and motor current. The DC motor requires more current than the AVR microcontroller outputs. So we need a driver. We use from L298. The L298 has two H bridges, each of which can control a DC motor. The H bridge can work with a voltage of 50 volts and a current of 2 amps. But the control circuit is in the TTL voltage range. We use PWM method to control the speed. Also use from Timer0 of AVR microcontroller. Components of project. Capacitor. ATMGA32. DC motor. L298. Dip switch. 1N4007 diode. Circuit schematic according to datasheet L298. It is recommended to watch video familiarity with the Proteus software environment. Porta for control OCR0. It is recommended to watch video AVR ATMGA32 microcontroller input and output configuration. With pins PB.4 and PB.5, we specify the direction of rotation of the motor. Run CodeVision. Porta, input with pull-up resistance. Pins PB.4 and PB.5, input with pull-up resistance. Pins 0 to 5 a port, output. Timer 0 configuration. Input clock, internal clock. Frequency divider. Fast PWM mode. Non-inverting mode. Enable both interrupts. We set the initial value of the TC and T0 register to 0, and the initial value of the OCR0 register to 80 hex. It is recommended to watch video AVR microcontroller timer/counter 0. Let's check. Overflow interrupt and compare match interrupt. Porta, input with pull-up resistance. Pins PB.4 and PB.5, input with pull-up resistance. Check 0 timer registers. Read 2 directional control pins, PB.4 and PB.5. Read the value of OCR0. Activate channels A and B. To apply PWM, write the code in the interrupt. If both pins PB.4 and PB.5 are high, both motors are forward. If pin PB.4 is 1, and pin PB.5 is 0, the motor A moves forward, and the motor B stops. If the base PB.4 is 0, and the base PB.5 is 1, the motor A stops, and the motor B moves forward. If both pins PB.4 and PB.5 are 0, both motors are reversed. Copy all of this code into compare match interrupt. Give the hex file to the micro. If you are interested in the topics of this channel, do not forget to subscribe. Thanks for watching.